Hello, geometry students. In this video, we're going to be talking about triangles once again. In fact, the title of this video is Obscure Facts About Triangles, Part 17. Just kidding. Actually, we're going to be talking in this lesson about inequalities in a triangle and theorems that deal with triangle inequalities. Because you know what? Triangles, just like you and me, want one thing: equal rights. All right, in this lesson, we're going to be learning four theorems related to inequalities in a triangle. And all of these are ones that just make intuitive sense. So if you're expecting some really deep, hard to learn content in this lesson, it shouldn't be that hard. Here's the first one. Theorem 39.1 states that if one side of a triangle is longer than another side, then the angle opposite the first side is larger than the angle opposite the second side. Does that make sense? The angle opposite the longest side of a triangle is the biggest. The angle opposite the second longest side is the second biggest. And the angle opposite the smallest side is the smallest angle. Pretty simple and straightforward. Theorem 39.2 states that if one angle of a triangle is larger than another angle, then the side opposite the first angle is longer than the side opposite the second angle. So this is stating the same thing, except we're doing it from the perspective of the angle instead of the perspective of the side. Okay? You can kind of think of these two as converses of one another. And if theorem 39.1 is a true theorem, then its converse is also true. The angle, if the angle opposite the first side of a triangle is larger than the angle opposite the second side, then the angle opposite the first side is longer than the angle opposite the second side. Now, I stated that as a converse. Notice that theorem 39.2 is stated much, much more simply as its own theorem instead of as a converse. But it kind of is a converse. Then, theorem 39.3. The exterior angle inequality theorem states that the measure of an exterior angle is always greater than the measure of either remote interior angle. You also remember we had an exterior angle sum theorem that stated that the exterior angle is the sum of the interior angles. Well, does it make sense that if you have to add two things together to make the exterior angle must be larger than either one of those two things because we have to add them together? Like I said, there's no real deep thinking, like really complicated theorems in this lesson. These are all pretty straightforward, intuitive, and they make sense. And then the last one, the triangle inequality theorem. The sum of the lengths of any two sides of a triangle must be greater than the length of a third side. And you can figure this one out by playing around with a triangle if you want to. You could play around with a triangle in um, GeoGebra just to see. But this one makes sense too, because if you think about it, the shortest distance between 2 points in two-dimensional space is a straight line. But if you have to go through two sides of a triangle to get from one point to another point, you're not going to be taking a straight line. You're going to be going at an angle, stopping at a point, and then turning and going at a different angle. So the side of the triangle is the shortest distance between those 2 points. Traveling through the other two sides is always going to be a longer path. Does that make sense? Hopefully, all of these make intuitive sense, because if they do, then the assignment is going to be a whole lot easier for you. Let's take a look at some problems here. Order the side lengths in triangle DEF from least to greatest. Well, this one's going to be really simple. D is 35, E is 85. I can figure out F from the triangle angle sum theorem, which states that there has to be 180 degrees in a triangle. So let's see, 85 plus 35 is 120. 120 plus 60 is 180. This is a 60-degree angle over here. What that means is if I'm ordering from least to greatest, the least side is going to be the one here. Let me just mark this 60-degree angle too. Okay, so the shortest side is going to be, make a P instead of a degree. Or let's try that again. There we go. Okay, so the shortest side is going to be the one across from the smallest angle. EF is going to be the shortest side. Then the next shortest side is going to be the one across from the next smallest angle. It's going to be DE. And then lastly is going to be the side across from the largest angle, which is going to be DF. There we go. Letter B, order the measures of the angles in triangle PQR from least to greatest. Well, again, across from the shortest side is going to be the smallest angle. So Q will be first. Okay, let me just get that. And then let's see, P is going to be second. That's across from the side 47. And then R is going to be the last one because it's across from the longest side. Show that in the triangle, the measure of the exterior angle at vertex Z is greater than the angle measure at vertex X or vertex Y. Well, here's how I'm going to do this. I'm going to use the triangle angle sum theorem to determine what the length of this side has to be. And once you know it, it's going to be 60 degrees. 70 plus 50 is 120. 120 plus 60 is 180. All right, now I'm going to note that 60 degrees, this angle, and A form a linear pair. Because these form a linear pair, the linear pair theorem states that they have to add up to 180 degrees because they are supplementary. So that means that I'm going to change this to, let's see, 60 plus 120 is 180. So this is a 120 degree angle. And there we go. The measure of the exterior angle here at vertex Z is greater than the angle measure at vertex X or vertex Y. There's another way to prove that was just by adding together these two. I did it a little more thoroughly, but that proves that this angle is greater than either of these two. All right, this last problem, letter D, is going to require for me to write out some inequality expressions to solve. This is going to be the hardest type of problem on this page. The other ones I could just look at and reason from the figures. Which one's the greatest? Which one's the least? What's the order from least to greatest? This one actually requires some inequality expressions. So let's get started. I notice that this third theorem states that the sum of the lengths of any two sides is greater than the length of the third side. So let's turn that into three expressions. 215 feet plus 165 feet has to be greater than x, right? If I add together these two sides, it has to be greater than this third side. Hey, just one quick word about the length of x. It looks like this is a specific triangle on this page with 215 feet and 165 feet, and then just one fixed length for x. But here's the thing. Whenever we draw figures in geometry, we just draw figures to represent a situation that's going on. We don't always draw them to scale for the specific lengths of all of the sides of the figure. Now, one of the things that Saxon does is where they have numbered sides, they always draw the numbered sides to scale. So this 47, is going to be a little bit longer in the drawing than this 41 is. And that's the same thing here too. 215 and 165 are to scale. But they just had to make a length that was X. But we don't know what this length is. It could be this long. It could be longer. It could be shorter. Now, just keep in mind, if I only know these two sides, I could swing this 215-foot side around so it gets closer and closer and closer to this 165-foot side. And as I do that, X gets shorter and shorter and shorter. Or I could swing it out the other way and make X longer and longer and longer. Right, there's actually an infinite number of triangles that have two sides, 215 feet and 165 feet, without knowing what this angle or this angle or this angle is. So X could take on a range of values, and that's what we're trying to figure out here. We know that if I simplify this inequality, 215 plus 165 is 380. 380 has to be greater than X. So X can't be any larger than 380. That makes sense, though, because if I add 215 and 165 together, that makes 380. And that would be like if they were a straight line this way, they would be 380 feet long. But then I don't have a triangle. So the X has to at least be less than 380. What's the smallest that x could be? Well, let's just figure out our other side relationships. Here's another side relationship. 215 plus x has to be greater than the other side, 165. Well, let's just look at this one for a second. 215 is a let's see, to get x on a side by itself in this inequality, I would need to subtract 215 from both sides. If I subtract 215 from 165, I'm going to get a negative value for x. X can't take on a negative value because it's a side length of the triangle. There's always going to be one relationship that doesn't matter. And in this case, it's this one. Okay. So we're going to go back in and see if we can figure out the other one that does matter. 165 plus x, if I add these two sides together, it has to be greater than the third side, 215. So I know that x has to be greater than, let me just get a lowercase x there. X is greater than, and then let's see, 215 minus 165 is 50. X is greater than 50. All right, now, I know that x is greater than 50 and x is less than 380. I could write this out as a compound inequality, and it would look like this. 50 is less than x, which is less than 380. So the shortest this could be is 50, this side down here. If this side was any shorter than 50, it wouldn't be a triangle. Uh, and the greatest this side could be is 380. Now, just note something here. If I subtract 165 from 215, so let's say this 215 gets swung all the way down here, so it overlaps this 165. That means that I'm going to have just 50 feet past. Like if I swung 215, so it overlapped, there would be 50 extra feet sticking off the end here, but it wouldn't be a triangle. It'd just be a straight line. And then if I swung 215 all the way around, so I had one line segment that was 380 feet long. Again, it wouldn't be a triangle. So what I'm saying is that x has to be some range between 50 and 380 for it to actually be a triangle. All right, and that's how you figure these out. You should be able to do the problem set for next time.